Fault finding, off-peak electrical supply. Safe isolation. Before starting work on the quantum heater, it is important to safely isolate the product from both electrical supplies, the peak supply and the off-peak supply. Equipment must be safely isolated. Follow G38 isolation techniques. Ensure all 12 steps are adhered to and the equipment is safe to work on. Only trained and competent persons are allowed to work on Dimplex heating and ventilation products. Dangerous voltages and switch neutrals can be found in many products. This is outside the scope of the fixed wiring systems. Off-peak circuit continuity testing. By the end of this short video, you will have an understanding of how to carry out continuity checks on the quantum heater's off-peak electrical circuit. Before proceeding, please obtain a copy of the wiring diagram. The quantum heater's main terminal block is located on the right-hand side and forms part of the charge controller PCB. The 230-volt off-peak electrical supply connections are as follows. Terminal 2 off-peak live connection. Terminal 3 off-peak neutral connection. Earth terminal. Storage element circuit continuity checks. Before starting, set the test meter to resistance and check it is operational. Short the test leads together and check continuity. Record the test lead resistance value. Here it is 0.15 ohms. Connect one test lead to terminal 2 on the main terminal block. Connect the other test lead to terminal H3 on the charge controller PCB. Record the circuit resistance. Circuit tested terminal 2 to terminal H3 on charge controller PCB. The heater size will dictate the actual resistance in ohms. Now connect the test lead to terminal H2 on the charge controller PCB. Record the circuit resistance. It should be substantially the same as H3. Circuit tested is terminal 2 to terminal H2 on charge controller PCB. Again, the heater size will dictate the actual ohms. Finally, connect the test lead to terminal H1 on the charge controller PCB. Record the circuit's resistance. It should be substantially the same as H2 and H3. Circuit tested is terminal 2 to terminal 1 on charge controller PCB, and again the heater size will dictate the actual ohms. The following approximate resistance values would be expected when testing between terminal 2 and terminals H1, H2 and H3. Quantum 50, 168 ohms. Quantum 70, 108 ohms. Quantum 100, 71 ohms. Quantum 125, 61 ohms. And Quantum 150, 50 ohms. Remove the test leads. In the event that these values are not found, further continuity testing is required to determine the issue. The following circuit diagram shows the test values expected at different points around the off-peak circuit. Fault finding, off-peak electrical supply. Again, before proceeding, please obtain a copy of the wiring diagram. Terminal 2 to peak circuit components. Terminal 2 to off-peak live on-charge controller PCB, less than 0.5 ohms. Terminal 2 to LHS cutout thermostat, in, less than 0.5 ohms. Terminal 2 to LHS cutout thermostat out, less than 0.5 ohms. Terminal 2 to LHS limit thermostat in, less than 0.5 ohms. Terminal 2 to LHS limit thermostat out, less than 0.5 ohms. Terminal 2 to top element live connection, less than 0.5 ohms. Terminal 2 to middle element live connection, again less than 0.5 ohms. Terminal 2 to bottom element live connection, less than 0.5 ohms. Terminal 2 to top element neutral connection, heater size will dictate ohms. Terminal 2 to terminal H3 on charge controller PCB, heater size will dictate ohms. Terminal 2 to middle element neutral connection, again heater size will dictate ohms. Terminal 2 to terminal H2 on charge controller PCB, heater size will dictate ohms. Terminal 2 to bottom element neutral connection, again the heater size will dictate ohms. Terminal 2 to terminal H1 on charge controller PCB, the heater size will dictate the ohms. It is also important to check the off-peak neutral connection to the PCB. Testing between terminal 3 and the PCB off-peak neutral connection, less than 0.5 ohms. Terminal 3 to off-peak neutral connection on charge controller PCB, less than 0.5 ohms. Thank you.